All right, welcome everybody. Thank you for joining us this afternoon. It's our pleasure to welcome Dr. Chester Ismay. Chester got a PhD in statistics from Arizona State University in 2013. He has since then been affiliated with some local colleges, Reed College and Pacific University, and currently he is a data scientist for DataCamp, where he develops and delivers online training modules for data science and R and other software platforms, but we're going to focus on R today. And so we as biostatistics faculty constantly get requests from our graduate students and others for more training in R, and DataCamp is one of the best resources out there, so please take advantage of it, and thanks again for joining us.
Yes, so thank you, Adam. Thank you all for coming. I want to tell you a little bit more about, you'll see about DataCamp, and I'll also talk about some other resources that are available for you for completely free, so at no charge to get you up to speed with data science. Another thing I want to make sure to say is DataCamp does not replace your education that you are getting right now. This is a very supplementary thing, so I'm not saying, oh, you should just completely forget about what you're doing now, your PhD or your master's, and just go directly to DataCamp. DataCamp is an excellent resource for helping you kind of think about how these topics work, getting you extra practice. So I just want to start off with that caveat. Okay, another thing that I do a lot, and I did this a lot when I was a professor, is I want you to talk to your neighbors. So I am going to start off and asking you to talk to somebody right next to you, and I'm going to say, you are learning something completely new. It doesn't have to be data science. Maybe you are learning how to, I don't know, road bike. You've never road biked before in your life, and you want to start biking on the roads. So I want you to talk for 2 or 3 minutes about what you would really like to have available to you as you learn those new things. And then in 2 or 3 minutes, I'll come back and ask you for some thoughts on that. And then we'll see how that maybe ties into learning R, learning data science, and getting practice doing that. So I'm forcing you to talk to your neighbors. Please talk to someone next to you for a few minutes. Okay. Thank you, that was awesome. I see many smiles and many happy faces, so that's always a good sign to start out a talk. So who can tell me one thing that they would like to have if they are learning a new thing? And feel free to just raise your hand or blurt it out. Yes?
Like a partner, someone to like bounce ideas off of.
All right, so a partner, somebody to kind of help you through this process, okay? I like that one. Who else has something different than that? Yes?
Examples and step-by-step instruction for backers.
Okay, so like a reference and just somebody else kind of walking you through what's going on first, okay? Yes, in the back.
Margaret talked about video tutorials.
Video tutorials, okay? So maybe you want to go to YouTube and learn about what road biking is or something like that if you wanted to road bike. Okay, so some nice tutorials, okay? Cool, so give me 2 more. What's something else you talked about? Yes?
Like a cheat sheet. I don't know if that counts the same as reference, but one that's more oriented from like the user's point of view or the learner's point of view.
Gotcha. Yeah. So something you can easily refer to that's really designed for beginners.
Yeah. To
try to just get you up to speed and be a nice little reference. Okay, cool. Yes, one more.
On a very basic level, factual materials and tools to do it.
Yes. Okay, so if you want to learn how to road bike, you probably should actually have a road bike, right? So that's a very important thing too. So easily accessible, getting into actually being able to use the tools. Okay. Okay, awesome. So you probably have a sense for why I asked you all of these things. It's almost like I talked to many of you before ahead of time, but I did not actually do that. So many of the things that you're talking about are ways that I think can help you in learning R and data science. Okay, so this does not solve all problems, but I want you to have a lot less of this. So if you follow me on Twitter, it's old_man_Chester, because I've never met anyone else named Chester, and when I do say my name is Chester, people always assume I'm maybe an older gentleman. It's a very old person's name, so Old Man Chester. So does everyone know who this is? Okay, so I see everyone that's like over 30 is going, oh yes, I know exactly who this is. If your college students don't know exactly who this is Zach Morris from Saved by the Bell. So we want some more. We do not want this, right? Like just constant eye rolls, frustration, you don't actually have the resources that you need. You maybe want something more like this, right? It's like, yes, I'm proud, I'm doing great things, I actually understand what's going on. So we want a lot more of that, right? And yeah, the slides, I tweeted the slides as well, but you can always find the link down here if you want to follow along at any point later. Okay. Okay, so some small thoughts. I'm not saying these are the cure-all, the end-all here, but these are just some talking points that I have, ways to kind of help you learn R and reinforce the learning that you might have. So first one is interactivity in small bits. So just give you a little tiny bit, let you play around with a little bit, and then come back to it. And then something that's really, really important, and you probably talked about this, you didn't say it, but like ways to actually practice what you've learned, right? So if you just watch the YouTube video, you need some like actual experience of you getting on that bike and actually going and doing it, right? You need some experiential learning and ways to practice what you have learned. So this was also mentioned, right? You need clear documentation and you need nice examples. Okay, so we did not talk before the talk, right? So this is important with anything, right? You need really clear guidance on exactly how to do some stuff with some clear examples. Maybe you don't want everything worked out for you, but you want to be able to follow something that has been done and apply it to your own problem. Okay, this is also super important. So as much as possible, you should be able to take the knowledge that you currently have and apply that over to something that you are just learning. So if you can make some sort of bridge between these two things, it's going to be way easier for you to learn this new context and these new problems. Okay. So those are my four kind of big things. I'm going to be talking about them a lot today. And every now and then, as we get into the R code, I'll pause, have you think about things, have you talk with your neighbors as much as possible. So I don't really like to talk, but I'll talk to kind of get you started here. Okay. So the first one, interactivity in small bits. So small lessons where you can test your understanding, right? So maybe it's a short video, kind of showing you how these things work. And then a little bit of an opportunity to test to see if you actually understand how that stuff works. Another really important thing with R is you should get immediate feedback, and more importantly, that feedback should be helpful. So I think everyone here has probably programmed in R, right? Or has at least seen it a little bit or programmed in something, okay? So do you sometimes get really weird error messages? It's okay just to go like, yes, yes, okay, so we all kind of get this, it's kind of confusing. So what something I'm gonna talk about just a little bit provides is maybe some more helpful feedback on some of those errors. We can't solve all of them, but as much as possible, we'll try to provide helpful errors there, okay? Also learn by doing, right? This experiential learning again, it's really frustrating, it's hard, your brain is like fighting back, your brain wants to take the easy route whenever possible, right? It's like, I don't want to struggle, I just want to relax, I want to take it easy, right? But actually going through those struggles helps you learn, helps you get better. So learn by doing, and also you need something that's actually brought forward to you and led by people that are really good at what they're actually using, right? So either they have practice doing it, or they can show you kind of how to do these things, okay? So what I haven't talked about here is what the first comment was, right? An actual kind of somebody else to kind of help you through that process, right? So I have to kind of think about how can we potentially do that from an online way as well, okay? And then lastly, a team of reviewers to kind of check to make sure that the things being presented are actually of good quality. So what do you think I'm talking about here? What's the next thing I'm going to click? Okay, yeah, so I'm going to go to DataCamp, okay? So I started working for DataCamp in June, and DataCamp is essentially this, okay? It's following all of these guidelines. Who has ever been to DataCamp? It's okay if you haven't. I just want to know who has ever seen DataCamp before. Okay, so just a few of you. So I'm going to actually demo this. I'm going to show you kind of what this looks like. So I'm also a huge fan of actually having just links all over the place in slides. So hopefully it's a good, nice reference for you to check things out. So if you click on this, it will send you to here. Okay, so this is the Introduction to the Tidyverse course. Who has heard of the Tidyverse? Just a few of you as well. Okay, so the Tidyverse is kind of like maybe like an R dialect. It's designed to kind of be a nice way for beginners to get up to speed with R, and then also for practitioners to use the same methodologies. Okay, so as much as possible, it's nice for both beginners and more advanced users. Okay, and it follows this Tidy Tools Manifesto. So if you want homework, I would recommend just Googling the Tidy Tools Manifesto that Hadley Wickham put together about the Tidyverse. Okay, so Dave Robinson put together this Tidyverse course. This was actually the first course that that I worked on with an external instructor. So Adam alluded a little bit to my job at DataCamp. I do build my own courses at DataCamp, but a huge portion of my job is essentially a technical editor for people that are building courses on an external basis with us. So at this moment in time, I think I'm working on 30 courses with instructors across a variety of different disciplines all over the place, R and SQL and Python. Okay, so they work on their course specs with me. So course specs are like they're brainstorming, getting kind of a nice outline put together, showing me some exercises, and then we go in and actually start developing the course. And usually that happens with somebody else on my team. Okay, so Dave Robinson was the first person I worked with on this. So I'm going to show you what this course looks like. So there's always an introductory kind of nice promo video. I'm not going to show you that here, but it just gives you like a 1-minute glimpse into what the course will be about. That's there. Then you can start the course for free. So there's going to be a video here. Like I said, I'm not going to necessarily show you this video, but you can check it out. The first chapter of all DataCamp courses is free. So we give you the opportunity to kind of hop in there, see what the course is about, test things out, and then if you like it further, you can get on to a paid plan. All right, there's a couple other options there as well. Okay, so this gives you some instructions over here on the left, right? So just a really small little piece. You don't necessarily have to read through all of this right now, but it's just kind of getting things set up. And then down here, there are some instructions. So it says, use the library function to load the dplyr package, just like we've loaded the gapminder package for you. Okay, so that's pretty useful advice here, right? So the student that's taking this course has just watched a video kind of talking about this, maybe in a little bit slightly different context. Now we're reinforcing that learning, saying, okay, I'm loading that first package for you, the gapminder package. Now I want you to do the same thing with dplyr. Okay, so you can go right in here and you can type library dplyr. Okay, so there's also a nice thing here the DataCamp does is it does an opening and closing parenthesis for you automatically. But a pretty common error is this, right? If you've done any kind of programming, you forget a comma, you forget a parenthesis, and that might kind of blow up your code entirely, right? So I wanted to kind of show you here what DataCamp does to kind of solve this problem. So you can always just do the run code button. So remember, you're going into R right now, right? You haven't installed anything on your computer, you've just signed up for an account, and you're writing R code without having to install any software. Okay, so this is getting to your point that you should be able to actually use the tools, right? So you could run this code in RStudio or in R, but it's right here, this is R running just in the browser for you. Okay, so I'm just gonna push the run code button, and this might be something that you see if you actually did this in RStudio. It says, unexpected end of input. It doesn't exactly know what's going on, right? So this is what I'm talking about with the errors not necessarily being really helpful, right? So instead, what you can do is hit the submit answer button. If you hit submit answer, it says, have a look at the highlighted code in the editor. Don't forget to close this parenthesis, right? So it said, oh, on line 5, I think I know what the mistake is that you did, right? So DataCamp does a lot of this kind of behind the scenes to help beginners get into programming and test that their code is actually working, okay? So that's a big added benefit. So I could do something, I could go back over here, I could test that out, I could say, okay, now I think I got it. And then I'll say, oh, wait, but it's asking me to do one more thing, right? Look at the gapminder data set. So this is a very clear instruction. It says type gapminder, right? So I go over here, I say gapminder. And then I could run that code, I can kind of see what the output actually looks like. So the gapminder data set, I assume you probably are all familiar with this, the Hans Rosling project. Gapminder shows you life expectancy, population, GDP per capita changed over time throughout the world. So I say, oh, I think I kind of understand what's going on here. I run the code, I'm gonna submit the answer now. And it goes through, it tests all of that, and it says, awesome. And then there's a nice little helpful message that says, notice how these things work, you can just print it by default, that sort of thing, okay? So I'm not gonna we can obviously, like I could go up here, we can walk through the whole course together, but I wanna continue on with the presentation now. Okay, and feel free to stop me, like if there are questions, I want this to be pretty informal, so just raise your hand if anything comes up. Okay, so that's DataCamp. Okay, so DataCamp has been around for about 3 years now. Started in just outside of Brussels, Belgium, Leuven, and then half the team started moving to New York City, to the US. So half the team is in the US, half the team is in Belgium, and then I'm out here in Portland. So I'm like DataCamp West is what I like to say. And there's a few other members of the team that are on the West Coast as well, but I think I was one of the first ones. Okay, so another important thing is you should be able to practice what you've learned. And these courses do allow you to do that, right? So you are gonna walk through, and then maybe at the end of the chapter there might be like a closing exercise to kind of reinforce and make sure that you understood the stuff that you were doing along the way. Okay, but you should also have different ways of practice. And what I usually say with practice is you should have actually different mediums by which you can practice. So say you're on a bus and you're looking for something to do, you should be able to pull out your mobile device and be able to study, be able to learn, be able to do something like that. If you don't have access to internet, your phone has died, maybe you should have note cards. You should have some way to be able to practice across a variety of different mediums. And you should also be able to just have very short, like if you're really exhausted, you don't want to study a ton, but you want to study a little tiny bit, that should be an option too. Okay, so short little checks, and then ways to apply what you have learned to potentially completely new situations. So DataCamp has really focused, for the most part, on building these courses like you just saw with Introduction to Tidyverse. Two of the newer things that we're working on, or three of the newer things that we're working on, are practice. So what you can actually do, and I'll probably probably click on this here, is you can hop in and kind of do Duolingo for data science. Okay, so you can actually go in and kind of practice and make sure that you actually understand what's going on. So I'm going to click off of this and try to open this in a new tab. Okay, so we're continually adding more and more things in here. So this is the joining data in R with dplyr course. So this is kind of related to what we were just discussing. Maybe not exactly, but you can kind of see what this looks like. So you can click on the start button, and then you're presented with some output here. So it says complete the script to produce the output shown. So you're given some output, you're given kind of some starter code, and then you can kind of look at this and think about what do I need to actually put in there to get the right answer. Okay, so I'm not actually going to test this out right now, but you kind of can look down here and see, oh, these are all the options that I have to potentially put in there. I guess I'll test it out. So let's say I would just do data frame. So I look at this thing, I get that output. Let's test to see if data frame actually works. You try the code, and it gives you that output. And you're thinking, wait a minute, that output does not match up with this output, right? So you can kind of test your learning and your understanding there. If you want, you get three options, three chances to try your code out first. And if it's not working, you can go and keep doing it. Or you could just say, I'm just gonna check it, I think it works. And it goes, no. That's not the right answer. You shouldn't use data.frame there. You should use the bind rows function instead. Okay, so this is a nice way to practice, that you have actually understood a lot of the concepts that were covered in that particular course. So right now, this practice mode follows along with this joining data in R with dplyr course. So what students would do is they would take the course first, get all the way through it, and they have access to this practice mode to kind of check their own understanding. And this is right now on the desktop, right? So they go to the browser and they can play around with that right there, okay? So that's the first option. Another thing that has just been released, this is pretty recently, I think in the last 2 months, is DataCamp Mobile. So if you click on this image, it will send you to datacamp.com/mobile, and then it'll have little links to the App Store on, let's see, the App Store on Apple, and then the Play Store for Google. And you can go and download DataCamp, and you can play through just some free R courses. So we have R and SQL and Python, and then we're continually building that as well. So we wanted to be able to have practice mode actually on mobile as well, and so you can kind of go through and play with desktop, and it should sync up with the mobile as well. So you have opportunities to kind of further do your learning there. Yes?
You say it's free now, but just earlier you mentioned that the first chapter is free. Is it because some classes you have to pay?
Yes, sorry. So every chapter, so the first chapter of every course is free. We also have many completely free courses. So the Introduction to R course is free. The Introduction to Python course is free across all of the different platforms. So you can do Introductory R as a course, Introductory R as a practice, and Introductory R on the mobile as well. So right now for mobile, I think all of the content is available for free, but very soon we will have some paid versions too. And I'll talk about pricing just a little bit too. Okay. Okay, any other questions on this? Okay, I'm doing way too much talking. I need another good break here, okay? Another thing that I kind of talked about a little bit is a way to apply what you have learned in a course and in practice mode to completely new problems, okay? So we've launched this thing called projects, where you can start up a project, okay? So this gives you some instructions, but not nearly as many instructions as what you see in a course. So this is more open-ended, but we still need to be able to check some things along the way, right? So maybe you have a full analysis, and maybe we're checking every 25% of the way through the analyses that your object works, or that your object is of the right format. Okay, so you still get instructions here. Currently, we're using Jupyter notebooks for both R and for Python. Does that make any sense to any of you? Okay, so Jupyter notebooks are like kind of like R Markdown, but not exactly. That's like over on the Python side usually. But right now we support all of these different things, and it's easiest for us to kind of have everything in these Jupyter notebooks. So the notebook has some text here with some descriptions, and then it asks you to perform some procedures corresponding to instructions, and you can kind of just keep scrolling through here. Okay, so the goal here is to be able to analyze new and different data sets, applying the skills that you saw in your courses. Okay. Okay. So there are a variety of different ways that you can get started with DataCamp. So I have links to our 5 currently free courses introducing you to some different technologies here. So the R course was actually the first course that was ever created at DataCamp, Introduction to R. So essentially we were an R company only for like the first year and a half. So if you look at all the courses that we have available, R is way ahead of Python, and we're trying to rectify that and get caught up on the Python side too. So you can do R. The first course that I ever built at DataCamp was actually a SQL course, so it's the follow-up to the introductory course in SQL about joining databases together, Python, Git, and Shell. Okay, so you can, right now you can go and click on these and you can go play through them. It's completely free, and I don't imagine that's ever going to change. We're always going to have these free courses to kind of expose people to what the courses are about. Okay, now to the professors and academics in the room, what you can do is click on this link right here, and you can sign up yourself and all of the students in your class for DataCamp for free for 6 months. Okay, so you can actually have a chance to go and look through how they're progressing. You can assign individual chapters from courses. You can assign entire courses. You can even create your own free courses. So this is actually how I first heard about DataCamp. I went to a conference. I saw a DataCamp presentation. They told me this exact same thing. I was teaching at Pacific University. I didn't like grading homework. Okay, nobody likes grading homework, but I wanted to get students immediate feedback on their stuff as fast as I possibly can. And unfortunately, when you have 30 students, you're looking through all their Markdown documents, you cannot provide them with immediate feedback. So when I heard about DataCamp and I could build my own course, and I could just have DataCamp already kind of do the grading for me, give them all the feedback back, that was awesome. So I built my own DataCamp course for free first, and that's what I assigned to students for their homework throughout the course. So essentially, I did a bunch of work for DataCamp before I ever started working at DataCamp. Okay? But it was an incredible experience, and it was really nice. And I could track the progress of students. I could see what the students were kind of struggling with. All that kind of stuff was available for me and for academic groups. Okay, so we have these different things called academic groups, and then we work with businesses to have business groups as well. So that's an excellent opportunity there. If you are interested, if neither of those opportunities work, and your professor will not sign up for DataCamp for academics, you can also join, and you can just click on this button here. I'll go to it right now. datacamp.com/pricing. So, yeah, I already have an active subscription. So I'm going to log out of this. And go to datacamp.com/pricing. Okay, so we have a free plan, costs you nothing, gets you access to a bunch of different things. If you sign up for a year, it's $25 a month, and you can do month to month for $29 a month, okay? So that's, you can take as many courses as you want for $29 bucks, okay? That's pretty affordable, and 2.5 I think it's 2.2, yeah, close to 2.2 million people have signed up in some form and have tried out our platform just a little bit. Okay, so that's the pricing. Does that answer questions about pricing? A little bit? Okay, cool. Yep. Okay. So, documentation, okay? So, DataCamp also owns a website called rdocumentation.org, which provides nice web pages with help manuals, all that kind of stuff. So that's one plug there. If you're searching for a function and you need extra help, you can go to rdocumentation. But I think what's really important with examples is the data set should actually be interesting. So if you look at common R tutorials, you see one of two data sets. Can you name those two data sets? Empty cars. So this is like 1970s car data. That's cool. Or what's the other one? Biology based. The dreaded iris. Okay, so that's perfectly fine, it's interesting, but my gosh, you can only look at this data so many times, right? So I think it's really important to actually find interesting data sets. And then interesting is a little bit subjective. Lots of people think interesting means a lot of different things, but it should be different than these very classic examples. Yeah, and I think this was mentioned before, the content should be written with the beginner in mind, right? So it's perfectly fine if like the experts in the field can talk about these things, but if the beginner can't really get used to it and work with it, it's only so valuable, right? So the beginner in mind at all times, and materials should be modern and kept up to date. Okay, so this is also a very tricky thing, right? You have a textbook, all of these open source tools are changing all the time. Textbooks have to kind of keep up with that too, and you get new editions of books all the time, right? So a suggestion is to shift to a textbook that I have written, co-authored, called ModernDive. So this is a modern dive into data with R. So if you click on that link, it's moderndive.com. I have a bunch of different hex stickers if you're interested. Who knows about the hex stickers in the R community? Nobody? Okay, so that's awesome. So it's a little tiny hex sticker, 6-sided, and you'll see it on computers. If you're in a coffee shop and you work on stuff with R, it's a nice little thing. You can see the packages that people like. It's a really easy way to start a conversation. Okay, so ModernDive is all R based, so we got some hex stickers created as well. Okay, and we like to think of ModernDive as software. Okay, so instead of having maybe version 1 of a text or edition 1 or 2 of a textbook, we want to have versions of a textbook, just like you see with software. Okay, so you can go to moderndive.com, or you can check out kind of the cutting edge as we continue to update this and make little tweaks at moderndive.netlify.com. So my co-author, Albert Kim, uses this in the classroom, and so his students are always giving feedback, and we're tweaking things and making things better. And eventually, we're hoping these two kind of things taper off, and the developmental version doesn't have very many changes, but over the last year, we've been constantly trying to develop this and make it better and better. So the first half of the book, I'll talk about this later, is really solid, we think, and it has a lot of good examples. The stuff is really good. The later half of the book is still kind of in progress, and we're working to update that now. Okay, so it's kind of an important thing that we're just saying, it's not quite done, but we're working on it, right? So we're putting ourselves out there. We would love some feedback on this as needed. Okay, so here's a layout of how the book is designed. So there's an introductory chapter, just talking about why we thought this book was needed, who the target audience is, all that kind of stuff. If you have friends that you would like to get into using R with, or like to build a community, you want to have somebody else to work with on these sorts of things, chapter 2 is really designed for that person. So it's walking through exactly what R is, what R Studio is. You'll see some images later on that we added for analogies, to try to just give people a sense for what's going on here. So those are the first two kind of introductory chapters, and then we get into doing data viz as fast as possible. So I think data visualization is really the gateway to statistics. It's the gateway to data science. It's what everybody likes. Everybody likes pictures and being able to interpret those pictures. So the focus kind of all throughout the book is on data visualization. So we say get students up to speed on doing really cool data visualization as fast as possible. And then you kind of get through more of a data science sort of the circle there with data wrangling, getting data in the right format, via tidy data. That's kind of the first part of the book that we've spent the most time on right now. Albert recently has updated the book to add basic regression chapters, so this is a nice kind of transition into doing more statistics while still using data science concepts. And then 8, 9, and 10, I'll talk about throughout the rest of this presentation with a couple packages that we've developed to make this easier. a nicer transition from data science. Okay. So, like I said, the book, as much as possible, and we're always looking for feedback on this, is designed for the novice, someone that has no experience at all, as much as possible. I think it's important to write that. But you also have to make sure that the book is like not ridiculously annoying for people that actually do have a decent background too. Like if you're walking through things over and over and over again, there's a nice balance that you need to make here. So this was the most common question that Albert and I got when we were teaching. Wait, what? There's R and there's RStudio. So what is RStudio? Does that like let me look at things in R? Can I just install RStudio without installing R? And it was just very, very confusing for students. And Albert's really good at analogies. So he said, RStudio is really the dashboard, right? It's the steering wheel. It lets you kind of play with things that's going on behind the scenes, whereas R is the engine that's running behind the scenes. Okay, so that's a really nice analogy, I think, for getting people started. This is a very recent development here, that if you think about R, when you first install R on your computer, that's just like you got a brand new phone. Okay? Now there's this weird concept that I just already exposed you to of loading packages in R. Students never quite got this. Wait a minute, there's a library function. What, why doesn't this stuff already just all come by default? So you say, you got a new phone, your new phone doesn't have Instagram installed, right? You gotta go to the App Store, you gotta download that app, and then you can open that app. And that's essentially what is going on when you do install.packages. You go out to CRAN, so CRAN kind of acts as the App Store. You download those packages, and then you run the library function to open them up. So you actually have access to everything that's in there, okay? Now, Albert's just started using this with his students, and it was like that, they got it, right? So we need to try to figure out analogies that help students and help people that have no clue what's going on with data science actually understand what that terminology means, okay? All right, so I'm gonna have I'll have a question for you very soon because you all are looking at me like, I want to talk to my neighbor. Okay, I'll let you talk to your neighbor. Okay, I'm building up all of the details here as needed. So, who has done stuff in ggplot2? Okay, just a few of you. Okay, that's good. So this is maybe more of a base R university. We're slowly shifting to the tidyverse, that's okay. And dplyr, so who has seen the code that's here before? Or something similar? Who's used the filter verb? Not very many of you. Okay, so I'm gonna actually talk about this code a little bit, and then further understanding this code will help you understand what I'm gonna talk about in the packages that follow, okay? So this is in the tidyverse. So this is all R code. This works just fine in R. But I think a big part of the tidyverse is if you've never seen R code ever, there are little tiny funky things that are a little bit hard to think about here, but you can just read this code. Okay, so let's actually read this code and just talk about maybe what's going on, okay? So we already know how to load packages. So we've loaded the Gapminder package, right? So Gapminder is really just a data package. It gets you access to the Gapminder data set. The tidyverse is a little bit confusing. The tidyverse is actually a meta package. It installs like 20 packages that Hadley Wickham and his team have installed. So you don't have to go through and individually install every single one of them and load every single one of them. You can just kind of load a lot of them all at once. Okay, what does this thing do in R? Here's your chance. Assigns variables, right? So this is might be like an equal sign in other languages, right? This is the assignment. It's saying take the things on the right and put them into something called the thing that's on the left, right? So we've created an object here called Gapminder _ 2007. Okay, so what does this code do right here? So there, what's that?
The filter part of the data.
Yeah, okay, so filter, remember these are verbs, and the verbs are the functions as well. So you filter to only include year 2007, right? So there's a variety of different years in this data set that go 1952, 1957, 1962, and so on and so on and so on. This is saying just pick year corresponding to 2007, okay? Now the one funky thing here is this thing, right? What is that? Does anybody know what the name of this thing is? It's 4 letters. It's called the pipe in R. Okay, so the way to read this is and then. Okay, so I'm going to actually read this line of code here in English. Okay, the Gapminder 2007 data frame is created by taking Gapminder, a bigger data frame, and then filtering it to only include the year 2007. Okay, so like this is when you're just learning Spanish for the first time, right? So it's a little bit tricky to get used to that language, but now it follows throughout a lot of the different kinds of things here, okay? So the tidyverse is 2 things. It is stuff that looks kind of more like this, using the pipe. That kind of came after Hadley Wickham had decided to use the plus here. Okay, so there's kind of 2 different paradigms here, but visualization is actually a little bit different than data wrangling. Okay, so when you see a plus in ggplot2, you can think of this as adding a layer to your plot. Okay, so essentially you have a blank canvas that you start with, and then you're saying, I want to add on more stuff. So I'm going to add on some points in this case. Okay, so let's just read over what might be happening here. Okay, so what is going on here? So ggplot takes a data argument, right? So this is telling ggplot, there's all these different objects potentially that you have. I want you to just focus on Gapminder _ 2007, okay? Now in Gapminder 2007, there are a variety of different variables, right? There's GDP per capita, there's life expectancy, there's population, and then there's which continent it resides in. Okay, so I want you to talk with your neighbors, and maybe if you have a piece of paper, I want you to start kind of sketching or thinking about what this plot looks like. If you have the slides, you can click to the next one, you'll get the answer, but don't do that, okay? So talk with your neighbors for just a brief second about what this code might look like, and then we'll come back and revisit. Okay, so what's this plot look like? So maybe what's on the axes? So this is the easy one, right? So what's on the horizontal axis? GDP per capita, right? Okay. What's on the vertical axis? Life expectancy, okay? I don't know how to say what the next things are without just telling you the answers, right? Maybe what's the type of thing that is being plotted? Are these bar graphs, histograms, lines? Points. This is a scatter plot, right? So the geometry that is being added to this blank canvas is a point. So each row in the data set corresponds to 1 point. Okay, so each point is sized by the population according to that country in that year, right? Remember, year has already been subsetted here, so we're only focused on 2007. Okay, now what's the color of continent do? It colors each one of the dots according to what continent it appears in. Okay, so I hope that I've just led you into this plot. Okay, so we have colors here. This is not colorblind friendly, so sorry if that is a problem. So there's red, yellow, green, blue, and purple. Okay, and then population accordingly for the size of the dots. Okay, so now that you've seen the answer, it's pretty easy, I think, to kind of go back and see how each one of these things maps from the aesthetics. That's why the AES function is there. Maps the aesthetics to each one of these different variables. Okay, so that's ggplot. Okay, so I might not get through everything here since I have 20 minutes remaining, but I want to kind of motivate how we use this to motivate some further statistical theory kind of things. Okay, so how can we use this to learn about sampling distributions? Everyone's favorite statistical topic, right? So sampling distributions leads into something like the central limit theorem. This is usually when I taught introductory stats at the undergraduate level. Students were like, yeah, data viz, woo, this is so cool. We get the first exam, everybody does well, and then we get the sampling distributions, and people just hate statistics all of a sudden, like, ugh, this is bad, right? So what I'm thinking is, how can we take the things that were the really cool, powerful tools that they saw, and how can we use that to lead into sampling distributions, okay? So it might be a little bit awkward, but I'm going to show you something that Amherst College has. This is, we do not use the word earn anymore either, okay? Students do not understand what an earn is, so stop using that word. This is just a big bowl, okay? This is a big bowl of balls that are white or red, okay? So we're kind of lazy, and we don't want to necessarily count how many red balls are in this thing, right? We just want to be able to maybe take a sample via this little shovel scoop thing and just take a sample from there and get a good guess for what that might be, okay? So you've all probably seen sampling distributions a little bit, so kind of think about how you first learned that and how that might help you here. Okay, so in this package on CRAN, we have a package called ModernDive that corresponds to our textbook, and we have a data frame called bowl. Okay, so bowl just lists out a bunch of different balls, each organized by an ID, and then whether or not they are red or white. Okay, so not necessarily super fascinating, but it corresponds to that kind of bowl that you saw, the big bowl. Okay, so what we usually do for activities here is students walk up, they take the little shovel, they pull it out, they count how many reds that they have. They do this over and over and over again, right? And then what do we do with all of those different observations? All of those statistics that we've calculated, we plot them, right? And then if we do this over and over and over again, we start to see, oh, this thing kind of looks normal, right? We kind of get this shape coming out. That's where the central limit theorem comes about, right? So students do this tactile activity first, and then we kind of head into R and have them do even more and more and more to further reinforce the idea. Okay, so instead of actually going in and doing a scoop with this, let's take a virtual scoop. Okay, and I was joking with Adam earlier, but why do you think I set the seed to 1977? No awkward comments? Random number, it's a reasonably random number. Nobody's going to say it? Okay, I assume that you'd say, that's the year that you were born. No, I'm not that old. Okay, this is the year the Portland Trailblazers last won the NBA title. Okay, so 1977. Okay, rough joke. All right, so set the seed to 1977. So this is assuming if you run this exact same code, you get this exact same sample, right? So this is a nice way to kind of reinforce those ideas. Okay, so we see here that we pulled out a bunch of different ball IDs with the corresponding colors, and then we have 50 in total, right? Okay, that's one virtual scoop of 50 balls. Okay, so what we can do is calculate the proportion that are red. This is one thing I really love about R. This is actually a pretty cool trick. So if you take the mean of color matching up with red, what R does is it turns color equals red throughout that entire sample. It turns those into trues and falses. So it goes through and it says, oh, color equals red, this one's a white, so I'm gonna turn it into a false. Then it goes throughout all of those, and so we have now a new column of trues and falses, right? Now R says, oh, you want me to take the mean of a logical value? Oh, you want me to take a mean of this? So I'm going to take all of the trues and convert those to ones, all the falses and convert those to zeros. Okay, so that's a little bit weird. Now what happens when we take the mean of a bunch of ones and zeros? We get, you sum up all the ones and zeros, so maybe there's 20 successes here. You go 20, you take the mean of that, divide by how many there are. What do we just figure out? The proportion that are actually red. So if you take the mean and you want to make a matching comparison here, you can use this kind of cool function, mean on that thing matching up. Okay, so it's a big kind of long-winded way of saying 36% in the sample are actually red. Okay? So, the question that we always ask the students next is, okay, 36%, so if we go back to the actual big bowl, it must be 36%, right? No, so some of you say no, so what's going on here? Why is it maybe not 36%?
Because you are basing this data in one observation.
One sample, right? So we've only, actually in the whole bin, there's thousands of different balls, right? So we've only taken one sample from there of size 50, right? So if we took a different sample of size 50, we might get the same answer, but more than likely we get something different. This is the concept of sampling variability, right? So what you can do is further do this over and over and over again. So there's a function inside ModernDive called repeatedly sample n. Okay, so repeatedly take samples of size 50, and let's actually do that 10,000 times. Okay, so you can think about what that data set might look like. Now there's a follow-up data set. So what's going to happen when you repeatedly sample n is you're going to get another column called replicate. Right, so you do it once, it's just going to do replicate 1, and it's going to look at that sample and it's going to figure out, okay, this is red, this is white, this is white, this is white, this is white. Okay. Now what I want to do is for each one of those different replicates, I'm going to group them back together, corresponding to the replicate, and I'm going to calculate what's the mean red for each one of those different replicates. Okay. So this data set up here, right? This data set is massive, right? So how many rows are in this thing? You can just tell me what the equation would be. It's 50 times 10,000, right? So we have 50 times 10,000. It's a very long, big data set, right? What this one does is it takes each one of those 10,000 repetitions and compresses it down to a single number, the proportion of red that are in that group, right? So this is only 10,000 entries long, okay? So the next natural step is what we always would ask the students to do. Let's actually plot this and see what comes out. Okay, so we take our data, we call it bowl props, we map just one aesthetic here. So we just map one variable to the proportion red, and we're going to create a histogram, and I kind of tweak some things here to make it look nice. Okay, so 0.02, and we get this resulting thing out. Okay, so this is essentially using all of the tools that we saw with dplyr and ggplot to further build up statistical inference, or at least get students thinking about what sampling distributions are, what sampling variability is. Okay, and you can assign them a different data set, have them think about these things. You can also ask them, okay, so we use a sample of size 50. What happens if we use a sample of size 500? What happens if we use a sample of size 5? And it gets them thinking about how that actually changes from that tactile experiment of them pulling that stuff out, those balls out. Yes?
So in this online, I guess I could go into because I have a really hard time with students who are really happy, as you say, with visualizations.
Yes.
But they refuse to sign up for statistical because they're terrified.
So, sorry,
So
to do
you
what
have
with
this
visualization?
integrated in the course online, do you have this integrated already where exactly what you showed?
Yes, so this right here is chapter, I can show you right now in the book. So if you go to ModernDive.com or ModernDive.netlify.com if you want the developmental version, you can go right here to sampling.
Okay.
And it walks through this exact same stuff here. Okay, so it lays out a bunch of different terminology that we're going to probably be talking that they would need to know, and then in real life sampling, there's the exact same picture, right? So it's the exact same motivating example with a lot more details. Okay. It actually shows some randomly assigned student names here too, and exactly what the proportions were that they got and stuff like that too. Okay. Yeah. So this is not in DataCamp, but it is on ModernDive.
I was wondering how well correlated they are at this point, both like DataCamp and ModernDive.
Yeah, I'll talk about that in just a little bit too. So, yeah, I can't control everything about DataCamp, but I would love to try to get further integration. And my co-author is actually building a DataCamp course for us right now too. So it's really easy if I know people that are interested in education for me to just have, oh, would you like to build a course for us? And then that kind of combination goes together there. Yeah. So hopefully a lot more in the future, but yeah, I'll talk about that more in a little bit. Okay, so I only have 5 minutes remaining. There's a lot more I could definitely show you here, but I'm going to hold off on that and just skip to this new package that we're working on. So the new package that that has just been released on CRAN is called infer. So nice 5-letter package name here, and what it has is a series of verbs. And the verbs match kind of nicely along with like what you saw with filter, with group by, and summarize. with dplyr. So this is hopefully following in this same tidyverse framework where students have worked through dplyr, they've worked through ggplot, they really like that stuff, but they want to be able to continue to code in the same sorts of syntax. So what you do is you specify, and you can go back to the slides and look at the last example if you want a further example here, but you specify which verbs you would like to work with. So say you wanted to do something kind of like a t-test. You would specify the response variable is these numerical data, and then the explanatory variable is these groups, right? So the specify verb is where you would do that sort of say that this is response, this is what the explanatory is, and then you can, if you're doing something with like proportions, you could specify what the success argument is. So you could say, I want heads to be counted as the success. Then the next step, if you want to do a confidence interval, is you just generate. Okay, so you would generate however many samples you want to do. Who has heard of bootstrapping? Okay, so just a few of you too. Okay, so bootstrapping is one method that you could also use in this generation. So that tells it exactly how you would like to generate all these different samples. And then you would calculate and say, this is the actual statistic that I want to build for each one of those different bootstrap samples. So I always think of the example that I work through, that's taking a population and doing a bunch of sampling, right? You can also do it kind of in reverse. You take a sample and then you kind of go backwards via bootstrapping to what a potential population might look like. Okay, so it's kind of the opposite of what the sampling procedure looks like. And then you get a resulting visualization, maybe you get a standard error out. Okay, that's confidence intervals. Hypothesis testing is actually how we got this idea started. So we wanted to have a way to specify what the verbs were, or what the variables are that you want to work with, and then feed in a particular type of hypothesis test. So you could do like a test of independence, where you want to test for the independence of two different variables. Or you could do like a point estimate, where you want to see, I don't think that this coin is necessarily fair, so I could check to see, is the probability of the coin flipping bigger than 50%? Not the greatest of examples, but that's exactly kind of what I'm thinking about there. Then you do the same thing, you generate, assuming that the null hypothesis is true, a bunch of different samples. Then you calculate a given statistic, so like a t-statistic you could even do, and then you visualize and get a p-value out. Okay, so this is walking through the entire kind of process of what's actually happening behind the scenes with hypothesis testing, but it's the same common framework for almost all hypothesis tests, right here following the infer verbs. Okay, and I do encourage you to kind of walk through, so here's an example of kind of what that code might look like. Okay, so you specify, here we're just going to look at color. We don't have an explanatory variable, so that's why it's null. We want our success to be red. We generate so many repetitions via bootstrapping, and then we calculate just a proportion of success. Okay? And then you can talk about how the bootstrap distribution compares to the sampling distribution. One is an approximation. Bootstrap distribution is kind of an approximation of what the sampling distribution looks like. Okay, so future plans. Right now, I think the infer package is really good for beginners. So you can teach people how these things work. The unfortunate thing is we kind of had to implement the procedure for just a certain subset of cases. So right now we have like one proportion tests are built in, two proportion difference in means, two sample difference in means, difference in proportions, all those kind of classic tests that you've seen, those are kind of all hard-coded in here. But practitioners aren't necessarily going to be doing that stuff all the time, right? So we need to kind of be able to say, calculate stat and have stat just be maybe another function itself, right? So say you want to do hypothesis testing on a trimmed mean, you should just be able to pass in the trimmed mean function. Okay, so that's something that we're working on to make this nicer for practitioners. Another thing that practitioners are probably not going to want to do is repeat these steps over and over and over and over again, right? So we're going to have short kind of wrapper functions to compress a lot of that stuff down if they just want to get their nice answers out after they kind of have a good sense of how this stuff works. Okay. In addition to that, yeah, the infer part of the book, like I said, is not completely developed, but hopefully next week, if all goes well, I'll be able to put a lot of time into that and get that completely done. I'm also starting to lead more workshops on using the infer package. One coming up in April will be the first one that I'm doing on that, so actually getting some examples and showing people how to do this. I think that's just about everything. I just figured out how to make a cool dark themed logo as well yesterday for ModernDive. So both of those are links to the DataCamp's website and also ModernDive if you want to check it out further. Albert Kim is my collaborator on ModernDive. Andrew Bray at Reed College kind of got me started on this package just as I was leaving Reed and starting up at DataCamp. It was like a nice bridge project for us to work on there. These slides are all generated in R Markdown, so you can download the source code, you can play with that. This is just a web page, so everything is available online, and everything's on GitHub too if you want any of that stuff too. So I'm happy to stick around and answer questions. I'll be here for hours after the talk too. Thank you all for your time. Yeah, any questions, let me know.